All right, guys, so welcome back. As we were saying, so I was asking the question, what would be the answer to the matrix A, or sorry, the matrix, when you square A square of the matrix, or you find the square of the matrix A, what would your answer be? And Ms. Wilson started to give us a solution. So what, can you go ahead now, Ms. Wilson, and tell us what your solution?
Yes, sir. I was saying 1 going across 9, 4 and 16.
4 and 16. All right. Is there anybody else that is in agreement with Ms. Waysome? Raise your hand. Anybody else in agreement with Ms. Waysome? Miss Green? Miss Green?
So I'm still working it out.
Okay, all right. Oh, so you're doing a calculation there, Miss Green, right? All right, Miss Caveira, are you calculating something too as well?
No, the same answer as Miss Wilson.
You're in agreement with Miss Wilson? Miss Caveira, are you in agreement with Miss Wilson?
Yes, sir.
Okay. Miss Green, let me find out from Miss Doherty. Miss Doherty, are you in agreement with Miss Wilson?
So I was trying to do the calculation to see if I get the same thing, sugar.
Okay. All right, so I'm just going to give you guys a little time to come up with your solutions. Are you anywhere close to your solution, Miss Green?
So I am finished.
All right, so tell me what is your answer?
Sir, I got 7.
Hold on, let me write your answer here. A squared is equal to 7.
Yes, sir, 7.
Oops. Let me write it properly. 7. No. This thing really having its way with me. All right, so you have 7. Continue.
10.
Across, down below.
Down below, sir.
All right, so we have 10. Then
13.
13.
And then 18.
And then 18. All right. All right, now, in conclusion, this would be incorrect. I'm not sure if Miss Green's answer is correct, but when we talk about the square of a matrix, what we are really doing is that, so A squared in this case is equal to the matrix A by the matrix A. So I'm multiplying the matrix A by the matrix A. All right, so just to check to see if Miss Caveira's, no, Miss Green's calculation is correct. So let us do that. So we would have 1 times 1, 1, 3 times 2, 6, plus 1 give you 7. All right. Now for this one over here, we would have done the first row with the second column. So 1 times 3, 3. 3 times 4 is 12. 12 plus 3. Let me say that again. 1 times 3, 3. 3 times 4 is 12. So 12 plus 3 will give you how much?
15,
15,
sir.
sir.
15. All right. So Miss Cabrera, not Miss Cabrera, Miss Green, check this calculation. So that's 1 times 3, 3. 3 times 4, 12. 3 plus 12 give you 15. All right. So let us check the other one. So 2 times 1, 2. 4 times 2, 8. 8 plus 2 give you 10, correct. And then we have 2 times 3, 6. 4 times 4, 16. And 6 plus 16. Let me do that again. 2 times 3, 6. 4 times 4, 16. So we have, 16 plus 6 give you what?
22.
22. So this calculation, the calculation for this one and this one is off for Miss Green. But I think Miss Green has the idea of what to do. But the rest of you, are you clear on what to do now in terms of finding the square of a matrix or any power that the matrix is raised to? It means that you're multiplying the matrix by itself that amount of times. Or you write down the matrices that amount of time based on the power. Is that clear, guys? Raise your hand if that is clear to you. All right. So the next thing now is, so we have looked at this, this thing to note. This other thing to note is that so we are on the third one. So we say matrix multiplication is associative. What do we mean by associative? Anybody remember what the associative law states? So if we are multiplying in terms of numbers, if we're multiplying 3 numbers, and let us represent them with letters A times B times C, and we are looking at the associative property. Anybody remember what the associative property states?
So like the way in which the number added or multiplied, it does not affect the sum or the product.
That's not the associative law. That's not what the associative law states.
Sir, is it the one where it doesn't matter how you would put the layout, you would still get the same answer? Like if you have 2 plus 3 give 5 or 3 plus 2 give you 5?
So it's a 2 plus 3 is equal to 3 plus 2. That's one you're talking, Ms. Sosa?
Yeah.
This one is not the associative law. This is the commutative law.
Oh, okay, sir.
So the associative law, remember we say that when we're talking about associate, think of the word associate. When you're associating people together, we put them in a group, that's all. And when you group things in mathematics, we put them in
Bracket, sir.
bracket. So what can you say about the associative law now, based on our model?
You work the bracket first.
Well, no, that's not what the law is really saying. Work in the brackets first is that has to do with the sequence of operation laws where we look at bedmass. So that's not the law. The associative law says it doesn't matter how you associate numbers when you are multiplying them in groups. So wherever we put the bracket, that's the association that we are making. We are associating A and B on this side, and So on the left side, we associate A and B by putting them in brackets. And on the right side, we associate B and C by putting them in brackets. So the associative law states that it doesn't matter how you group in brackets when you're multiplying, the answer will be the same. So if you multiply A times B in brackets, then A times C, you will get the same as multiply B times C in brackets and then times it by A, you will get the same answer. That's the associative law. So we are saying that matrix multiplication obeys this law. So if you notice when we were multiplying the three matrices just now, you would have multiplied P and S, the matrices P and S first. And so you actually associate them in that sense. And then after we get that product, we times it by R. So that's the associative law. So we are saying that suppose you decided that you want to associate it this way. P, so you would have associate the S and the R together. That means you would work out this bracket first. So it's multiply R times S. Then you use that to multiply P. Remember, you have to keep it in the same order. So you would multiply R times S, and then you would put P on the left side and times it by the product. So if you do that in the same order, where P, S, and R are in the same order, you will get the same results. That's why we are saying that matrix multiplication obeys the associative law. Is that clear to you guys? Raise your hand if you understand what is being said. All right, so Ms. Green, Ms. Cabrera. All right, good guys. All right, I'm taking it that Miss Dorothy and Miss Waysome understand the associative property. Raise your hand, please. Okay. All right, so the fourth notice that I want to bring your attention to, so we're looking at this one. It says that if the matrix A is of the order 4 by 3, so the order of this matrix is of 4 by 3. Oops. I really need to get the handle on this. So the order of this first matrix is 4 by 3, and the order of the second matrix is a 3 by 2. Then the matrix A times B, meaning when you multiply, so all right, so this is what we're saying. So you have the matrix A, which is a 4 by 3, and you're multiplying it by the matrix B, which is a 3 by 2. Then the product, which is AB, which that would be the final matrix, will give you the order of 4 by 2. All right, so can anybody make any connection from the order of these matrices? How you think the order of the product came about? Or would be the order of AB, which is 4 times 2? How do we arrive at this order? Anybody? Can anybody see anything based on what the two matrices that we multiply? Can you see anything from the order of those two matrices that would suggest how we get the order of the product?
Sarah, the column and the row are 3, 3.
All right, so these two are equal. So these two tell you that the matrices can be multiplied. Now, what else can you say? How would we arrive at the 4 by 2 for this AB?
So the first letter in A times the first letter in B, the second letter in B.
Exactly. So in other words, you can actually say what order the result going to be by looking at the row on the first by the column of the second matrix. So if you use the row of the first matrix by the column of the second matrix, it will tell you what the product, the order of the product will be, which is 4 by 2. Is that clear, guys? Raise your hand if you understand clearly what is happening here. All right, Ms. Caveira, understand. Ms. Raysom, or Ms. Green. Ms. Raysom,
Yes, sir.
you reach home as yet?
Just now, sir.
Oh, are you following so far?
Not quite.
Okay. I think you'll have to watch the video. I'm going to try and get these video posted by about tomorrow so that you are able to access them.
Okay.
And I'm apologizing for the delay, the delay in the posting of the videos. I had some, what I must say, some situation that I had to deal with from Monday of this week. That's the reason why we didn't have class, and that's the reason why the posting of the videos are also delayed. And I'm so sorry about that. But anyways, I'll try to make the video available for you to review it, Ms. Waysom. All right, so moving along. So everybody understand these things, and you have to bear them in mind when you're carrying out any kind of matrix operation. All right, here we have one more thing to note. So the last thing from the list of 4 that we had before, there's a final one, which is 5. We say that the 2 by 2 matrix I is the identity matrix. So it means that, I mean, you would have learned about what the identity matrix is from before. And it is a matrix that you must be very familiar with, meaning that you should commit this matrix to memory, because if you're asked what the identity matrix is, you should be able to write down this matrix. All right, now, the property of an identity matrix is that if you use it to multiply any other matrix, you're going to get back the same matrix. So if you multiply the identity matrix, and let's say I is the identity matrix, and you multiply it by another matrix, A, you will get back the matrix A. Now, you can also multiply the other way around. So we can say A times I, and you will still get back A. Now, my question to you, based on this property that I'm writing here, let me write this A times I, we would get back A. What can you conclude about multiplying by the identity matrix in terms of the associative, not the associative property, but by the commutative property. What can you conclude from what was what is written here? Anybody remember what we were saying about the commutative property? Remember what the commutative property means, Ms. Waysam?
Sir, can you repeat?
I'm asking you if you remember what the commutative property is.
Yes, sir, where it doesn't matter how the number is added or how it is multiplied, you get the same answer.
All right. Now, all right. Say it a little clearer than more precise is to say
All right, sir, for example,
the order in which you arrange numbers when you're multiplying them does not affect the outcome. It doesn't affect the result. So if you multiply A times B, you will get the same as B times A. So that's the property. And if you add A times B, if you add A plus B and B plus A, you'll get the same answer. So commutative property works with addition, and it also works with multiplication of numbers. But remember early on, when we're looking at the things to note, remember I said that two matrices multiplication, and multiplying two matrices together. They are not generally commutative when you multiply them together. So if you have two matrices A and B, and you multiply the matrix A by B, and then you multiply the other way around, B by A, you don't get the same answer in matrices. Not usually, that seldom occurs. But one of the ways in which you can get the same answer when you flip it around is when you are multiplying by the identity matrix. So if you multiply a matrix by the identity matrix, so you multiply A times I, it will give you the same answer when you multiply I times A. So what we are saying here is that the commutative property applies in matrices when you're multiplying using the identity matrix. So if you're multiplying a matrix with the identity matrix, you will see that the commutative property works. But if you're multiplying two matrices other than with the identity matrix, you will come to realize that the commutative property don't generally work, right? It may happen on occasion, but not all occasions. So it's generally not going to work when you multiply two matrices that are not, where any of them would not be the identity matrix. But it will work when you multiply a matrix by the identity matrix. All right, guys, so that is something to bear in mind. So this would be things to note number 5, all right? All right, so with all of that said, you have to bear in mind all of those things to note when you're dealing with matrices. Now, so we are going to be looking at equality of matrices and what that means. So two matrices are equal if, when you multiply them, so if two matrices are equal, their corresponding elements must be equal. So if you say that the matrix on the left is equal to the matrix on the right, it means that their corresponding elements are equal. So what we are saying, A corresponds with E, so it means that A must be equal to E if the two matrices are equal. All right. Now B corresponds with F, so it means that B must be equal to F if the two matrices are equal. All right? So once two matrices are equal, their corresponding elements must be equal. So C corresponds with G, so C and G will be equal. And D correspond with H, so D and H are equal. All right, so is that clear about equality of matrices? Raise your hand, guys. Raise your hand if you're understanding what equality of a matrix really means for the elements. All right. This way, some are you following?
What point, sir? But I'll just watch the video over to get the full understanding.
Okay, all right. So that's something to note, that if two matrices are equal, once you have an equal sign in between them, it means that you can equate their corresponding elements because they should be the same. All right. They are not the same, it would mean that the two matrices are not equal. All right. So with that said, moving on. Now, so here we have A equal to E, B equal to F, C equal to G, and D equal to H. All right. Now, we are going to be looking at now, based on equality of matrices, how we can solve for unknown. So when we talk about unknown, we are referring to the X and Y here. How can we solve for X and Y? All right, so the first thing that we want to do is to multiply the two matrices on the left side of the equation. And so we multiply them carrying out the same multiplication rule. Give me a second, guys. All right, guys, sorry about that. So I was saying now that first we have to multiply the two matrices on the left-hand side following the general matrix multiplication rule. And if we do that, we'll have first row by first column, we'd have 2 times x plus 1 times 5. That would give us 2x plus 5 for the first element in our product. So we'll have 2x I don't know why these things have to be given so much problem. So we have 2x, so 2 times x plus 1 times 5, so that gives us 2x plus 5 for the first element. So we take the same row with the second column, we're going to have 2 times 2, which is 4. And then we have 1 times y, which is y. So we will have 4 plus y for the second element in the top. All right, so in the row below, for the first element in the row below, we are going to use the second row with the first column. So 3 times x give you 3x plus, we are going to use 4 times 5, which is 20. And then now for the last element here, we're going to take the second row with the second column. So 3 times 2 will give you 6 plus, then we're going to say 4 times y will give you 4y. Now here, if they're asking you here now to find the values of X and Y, and you know that this matrix would be equal to this matrix, which is the 7, 23, so 7, 23, and then 10, 30. How can we calculate the value for X and the value for Y? Can anybody come up with an idea?
Sir,
Yes.
all right, since I said that it is equal, what I did was the 2x plus 5,
Mm-hmm.
I have 2x plus 5 equal to 7, and then I work the equation.
Correct, correct. So
Yes, sir.
following that, because based on what we just said about equality of matrix or matrices,
Yes, sir.
that the corresponding elements in the left side and the right side, or the left matrix and the right matrix, will be the same. So it means that 2x plus 5 would correspond to 7. So it means that these two would be equal. So you just form an equation with that. 2x plus 5 equal to 7. And then from that now you could just solve that equation for X.
Sir, but I got the answer as x equals 1.
All right, so let us solve it and see what you get. So if we bring this 5, when we are solving the equation, we want to leave X by itself. So we're going to bring over the 5 and subtract it from the 7. So we would get 2x is equal to 5 from 7, leave what? 2?
Yes, sir.
Right. So I'm kind of skipping out steps here. Let me write it in the correct way. So we would have 7 here minus 5. And then now we would now have 2x equal to 2.
2.
And then now to solve, we have to get rid of this 2 beside the x. So we divide both sides by
2.
And so
X would equal to 1, sir.
X equal to 1, which is correct. All right. All right, so we do the same thing to get Y. Now, if we already use one of the corresponding elements to solve for X, there's no need for us to use the other X corresponding element to solve the other one. Because once you solve it, you should get the same answer as 1. So you only need to equate one corresponding element with one of the elements on the right, in the right matrix, in order to solve for that value of X. Now, generally you want to equate the corresponding elements that are easier to calculate to make things easier for you, especially in exam. You don't want to be working with too much or too many complex numbers that you have to do a lot of calculation. All right, so to solve for Y now, we could, which of these corresponding elements you would use to solve for Y? Can somebody give me a corresponding?
Sir, they can use 6 plus 4y, which would equal to 30.
We can use 6 plus 4y and equate it to 30. But
Yes, sir.
I was just saying just now, is that it would be better for you to choose the easier one, which would be 4 plus y equal to 10 in terms of calculation, right?
Oh, for y, yes, sir, for sure, yeah.
So for y, you could just choose the corresponding element, 4 plus y equal to 10. All right, so choose these and solve that. So we would have 4 plus y equal to 10. Now, if you had used the other corresponding element, no problem, you will get the same answer. But in the interest of time, when you're doing an exam, you want to take the shorter route in the interest of time, right? Because once they say stop working, that's it. All right, so now we would bring over the 4 and subtract it from the 10. So we'd have 10 minus 4. And then y would be equal to, what y would be equal to here, guys?
6, sir.
6, 7.
All right, good. All right, so that's how we can use equal matrices, or matrices that are equal, to solve for unknowns. All right. Any question? Everybody is good with this? Raise your hand. All right, so with that said, guys, I'm going to end the lesson here for today. And then now we'll continue tomorrow. Now, what I will do, because I don't know if you noticed that because of us starting on Thursday, then I did not start off with the algebra topic, right? So on Monday, I will do the algebra topic. Now, in regards to the class on Sunday, let me see the hands of you who are still in agreement for us to have a class on Sunday at 3, ending at 5. All right. Okay, so it means that we will have that class on Sunday, 3 o'clock, and ends at 5. Now, for that class, I'll be looking at circuit theorem. Now, I know maybe the notes is not yet on the site, but what I'll try to do, I'll try to upload that notes on circuit theorem, and then I would like for you to read on circuit theorem before we